Hey everyone, welcome to part 6 of our DevOps masterclass. And in this class, we're going to dive into infrastructure as code. This really is a critical piece when we think about the all-up flow, about we having these pipelines, about having resources there. Well, infrastructure as code really helps us get those resources there in a predictable way. First, as always, a lot of work goes into creating these classes, so a like, subscribe, comment, and share really is appreciated, and hit that bell icon. I previously talked about pipelines. We talked about the idea that we have this pipeline, and at the start of any kind of pipeline where we're deploying some application, we're doing some testing, well, the first thing we have to do is kind of deploy the infrastructure. Now that could be virtual machines, it could be a Kubernetes environment, it could be databases, storage accounts, whatever that is, we have to have the infrastructure there first before we can put on our applications, our data. And then sure, we go and think about things like, hey, our application, we think about kind of unit tests and other things in that pipeline. But how do we do this? How do I get the infrastructure there? How do I make sure it's to my requirements? Maybe my requirements have changed. How do I modify what exists to meet whatever changes I have specified? I can't have some user going in a portal and clicking. I don't want to have to run commands. I want it just done as part of my pipeline. And when I think about infrastructure, realize there's layers. Sure, there might be VMs or Kubernetes environments I create in some fabric. Could be in the cloud, could be on premises. But then if it's a VM, well, what is the image that drives, that runs on that OS? What are additional middlewares or runtimes I have to install? What configuration is required? If it's Kubernetes, what builds the container image I deploy into the pods? Which pods do I deploy via whatever environment? If it's a database, well, what commands am I running to modify the schema, to create the schema? So there's all these different layers that build up my complete solution. And I have to have that to make all of this work. So when we think about the how do we normally do things? How do we create things? And I can kind of think about, well, there's imperative, and then there's kind of this versus declarative. And if we really break those down, if I think about imperative, it's really about I'm telling it what to do, how to do it. If I think about declarative, it's more about what I want. So let's think about those for a second. So imperative, what to do. I'm saying how to perform something, the steps I want performed. If it was a portal, click this button, then click that button, then type in this value, then click this button. If it was a script, it might be, hey, create a new resource group. Now create a storage group with this configuration. Now create this container. Now create this virtual machine. There's steps to perform. If I was traveling, and I like to use this kind of example, well, I could think about maybe there are some streets. I could think about, hey, there's certain streets here. And I think about there's a destination I want to get to. And maybe I'm starting here. So if it was imperative, I would be saying, hey, go forward 100 meters. Then, hey, you're turning left. Then you go forward 200 meters. Then you turn right. And then you go forward 50 meters. So that would be imperative. I'm telling it the steps to actually perform to get somewhere. And it works. From this particular starting state, I'm at my house, I would end up at that destination. So if I always followed those particular steps, I'll always end up at that destination from this starting point. But there's challenges. What if it failed halfway through? What if I was in the car and it broke down here and I have to get a different car? Well, I can't just replay those steps because now I'm going to end up somewhere completely different. So what if my starting point is changed? Those steps don't work anymore. So my starting state impacts this. This only works if my starting state is always the same thing. I can't just rerun an imperative list of steps. I'd have to modify them. I'd have to do checks to say, well, where am I? How can I tell what's actually the end result matches what I put in those steps? How do I know I'm at the right location? Well, I could kind of replay those through, but it gets very difficult. So how do I validate? How do I audit? How would I detect drift? How would I know I'm not at the right place anymore? How can I repeat? Like, how can I just rerun that to make sure I really am in the right point? If it was creating resources, can I just rerun the entire script to make sure I have those resources there? No. If I'm doing commands to say create a VM, well, if I rerun that command again, most of the time it would fail. So I would have to build into my script to say, hey, check if something is there. If it's not there, then go and create it. What about if I want to modify the goal, modify my end state? I can't just recreate the VM again with some different parameters. Again, it's going to error. I'd have to use a different command. I'd have to use a modify command to actually make it match my desired state. So it's really hard to kind of track that and do that in an imperative fashion. There's lots and lots of steps I'd have to write in to handle modifying my end goal, starting at a different place. How do I audit to make sure I really am there? And can I easily kind of version control and then detect what's changed? So it's very difficult with an imperative manner. Now, let's take declarative for a second. I'm saying what I want. So I could have that same idea of kind of the streets, exactly the same. And again, I have kind of that same starting point and the same destination. But in declarative, instead of me telling a driver, hey, go forward 100 meters, then turn left, then go 200 meters, then turn right, then go 50 meters, and you're there, it's kind of like phoning an Uber and saying, hey, I want to be at A. That's all I say. I want to be at A. It's then up to the technology to handle that. So all I do is state my desired final state. To be at A. That's what I put down. I'm declaring what I want the end state to be. So it's all about the goal, the final end state. And it's up to whatever technology I'm using, in this case, the Uber driver, to get me to A. It works out the steps to actually get me there. Now, if I was at a different starting point, my desire is still the same, to be at A, and it's up to that technology to work out what it needs to do. If I'm at A and I change my desired end state, hey, now I want to be at B, it has to work out how to do that. Whereas in imperative, I'd have to kind of work out a whole new set of exact steps and how to do that. So this handles all of this for me. So this gives me a lot of nice benefits. I want to be at A. I can say that over and over again. I can say that when I'm at home, when I'm at A, if I'm somewhere else. If I'm already at A, I can just say I want to be at A. And it's like, well, you're already there. So it's idempotent. I can just rerun it as many times as I want, and it will make it match the state. If I'm already at the state, nothing's going to change. But I can make sure I am at A. Hey, I want a VM in South Central of this type. I can just say that. If it already exists, nothing has to change. If it's of a different type, it would change. If it doesn't exist, it will create it. So it's idempotent, I can rerun it, which means it's totally repeatable. I can keep saying, hey, this is what I want, this is what I want. So in a pipeline, that's super attractive because I can just say, this is the infrastructure I want there. And if I run this pipeline 50 times a day, it does not matter. If the infrastructure is there already that matches my desired end state, because I'm declaring what I want, it's declarative, it doesn't have to do anything. It looks, says, yeah, it matches, I'm done. If it doesn't match, maybe it's the first time running it, it will go and create it. If in my desired state, I've modified what I want because of changing requirements, it will modify what's there to match my new desired state. So because it's declaring what I want, it's easy to validate. I can easily detect drift because it's looking at what's there, what's my desire. It can easily compare those two things because it's not trying to track, well, where would these steps get me? This is what I want. What is there? Does it match? What's the drift? And the nice thing, I can easily version control because it's just what is my desired end state. And if I change it, it's easy to look at the differences and say, oh, this was the desired end state. Now it's a new desired end state. It's easy to see what changed. Whereas again, if it's kind of imperative and it's a list of steps, it might not be obvious what the end state before was compared to what is the end state now. So this is huge. This declarative nature is what we want when we think about infrastructure as code. I want to just state the desired end goal, and the technology makes it so. It makes it so I can just always just rerun it to make sure I'm in that state. It makes it easy to see what has changed, audit it to make sure it's in compliance, version control. That's the desire. I want to be using a declarative technology. Now, there are different declarative technologies depending on what exactly we're doing, at what kind of layers we're leveraging. And I want to kind of touch on some of those. Now, I'm not going to go into huge amounts of detail about specific technologies because, again, this is a DevOps course. Your technology may differ, but I want to give some examples of some of the things you might use just to put it into kind of some real world scenarios so you do understand kind of what's going on. Now, the first thing to bear in mind is that many organizations today are using the cloud. Processes has changed. Now, the cloud doesn't necessarily uniquely make this happen, but it really did drive this change in behavior. And the reason for this is in the past, I could think about, hey, I had my business user, my app owner, whatever that might be, and they wanted some resource. Now, the way this would work, and I'll kind of say this was yesterday, maybe it's still today in certain environments, but this was how things always kind of happened in the past. So I had some request for resource, VM, Kubernetes environment, public-facing site, whatever that might have been. And the way this kind of worked is this went to the IT admin, the system operators. And the whole point here is that IT admin was aware of corporate requirements, of security, of regulatory requirements. And so they would kind of do a validation of the requirements. So again, that could be security focused. It could be regulatory. Maybe certain regions are allowed to be used based on data sovereignty. It could be based just around corp guidelines, maybe where we spend money, sizes we can create, allocations, whatever that might be. But the IT admin would kind of do that validation. So there was the request, there was kind of the validation, and then they would actually go and create. And they'd go and spit out whatever that resource is, VM, container, doesn't matter. But that was the flow. Well, so that was yesterday. If I think about today, and we think about this new cloud and this consumption-based nature and self-service, that doesn't work anymore. It's too slow. Think about auto scale and reacting very fast to requirements. We have the same app owner. Lost an arm. We have the app owner. But now and again, I'm drawing the cloud, but it doesn't have to be. I can do things like private clouds on premises where I can have self-service. But now that request essentially just goes direct. I'm using some technology to say, hey, create the resource. And it just creates the resource. Now, we still have this IT admin. Because I, as a company, I still have all those same things. I still have security requirements. I still have maybe regulatory requirements. I still have corp guidelines, etc. I still have all of those same things that I need. So how do we do that? I could educate the users. Probably not going to work very well. I could create set corporate templates that have some of this stuff in place. Again, may or may not work to different degrees because they can create things in different ways. They might ignore my templates. They might click things in the portal. So what we really think about is we want this idea, I'll do this here, we want policy. Now the exact nature of this is going to vary depending on the solution I'm using. Azure, AWS, Google Cloud, on-premises, Kubernetes, whatever that might be. But I want policy. And I think about that policy is this guardrail. And no matter how I create, provision a resource, the guardrail will enforce that. So this IT admin is not out of a job. Instead of reacting to each request and doing that validation, the IT admin now sets up these guardrails in advance before people start creating resources. And that is done through the creation of policies that apply no matter what I'm doing. So that's kind of this big shift that, yes, it's self-service, but the requirement to have those guardrails to make sure I'm not creating things in regions I'm not allowed to because of data sovereignty, or I'm not doing the right replication to make sure I'm protecting my business data, or I'm not creating these massive resources and spending too much for a dev environment. Those all still exist, but we can't rely on the user to do the right thing. So instead we think about this kind of policy idea. So that's the first thing. Before I even think about infrastructure as code, make sure you get the guardrails in place. So for example, obviously I'm an Azure person, so I'm always going to kind of use Azure as the example here. If I have my cloud, I want to use the native capabilities. So if this was Azure, everything in Azure goes through this Azure Resource Manager. No matter what I'm doing, if I'm using the portal, if I'm using PowerShell, the CLI, if I'm using some template technology, it doesn't matter what I'm using, they all go through the Azure Resource Manager, this RESTful API. So what we think about doing is I apply policy. So there's a technology, Azure Policy, that you can think about wraps around the Azure Resource Manager. Any request, no matter how I interact, goes through that policy. And so in the Azure Policy, I create the policies to meet my security, my regulatory, my corp standards, whatever that is, and it might vary. I do all of those things with Azure Policy. So it'll actually stop the request. If the request comes in, hey, create this, and it breaks policy, it won't let it get created. And that's far more useful than having some process that runs periodically and looks at what's already deployed and says, oh, you're out of compliance. Okay, now what do? Now I have to send an email to the app owner and say, hey, you create this out of compliance. They're going to argue with you. They've already got things running. It's live. It's very hard to clean something up as opposed to stopping it be created in the first place. Give them useful information about why it's out of compliance and actually stop those things. So I want to use the native capability at the entry point of the API, if possible, to stop it and get it enforced at the very start. And again, there's huge amounts of different things. It could be, hey, I need certain firewalls, certain network isolation, certain logs captured, a whole bunch of various things. Now realize as well, these policies I can use to enforce, actually stop something, or maybe I'm just checking, tracking for compliance. And when we think about those policies, we think about our pipelines, one of those steps could absolutely be check compliance state. Hey, we've done these deployments. Am I getting alerts from the compliance technology of my cloud to say I'm out of compliance? And how many? Maybe I have a certain threshold. Hey, more than 3 compliance warnings, I stop, I fail it, and have to go back and work out what's happening. So I can hook into that stuff actually in the pipeline itself. But my goal is to leverage that native capability of whatever cloud I'm using. Now, just a quick kind of demo of this. So if we jump over, and this was actually, I meant to kind of mention this at the start. Don't forget the GitHub repo for this class. It's filling out quite nicely all the sample code, the whiteboards. But I can think about, well, if I just go and look at policy, for example, and look at my notice straight away, I can see compliance state across this subscription in this example. I can see the types of policies I have. But if I look at definitions, there's definitions for everything across all the different types of technologies, all of these different things. Like I could look, for example, just at, let's say, storage. Something very, very simple. But even for storage, hey, I can check, hey, account keys should not be expired. Hey, I should use private link to protect the networking. Limited to only certain SKUs, so only certain types of storage account can be used. I'm using shared access keys. All of these controls are available to me. And what I can also do is, well, rather than having to start from scratch and work out, well, what are all of the policies I need? There are initiatives. Initiatives are collections of policies. And here you'd see, hey, look, FedRAMP moderate, for example. Hey, look, there's an initiative around FedRAMP moderate right here. And I could just assign that to certain resources. There's 262 policies that make up FedRAMP moderate. Hey, there's ones around FedRAMP high. There's ones around PCI, around NIST. There's all these different helping starting points. Now again, this is Azure, high trust, HIPAA, etc. But there's starting points I can use. And some of the great examples of things I might want to do is, well, look, certain storage account SKUs that I want to allow, i.e. certain replications. Maybe I want it to be globally resilient. I could have certain locations I'm allowed to use. So I've got this US locations policy. And notice some of them are applied at a subscription. They have a scope of subscription. Some of them I'm targeting particular resource groups, i.e. they're more granular. So you have this idea of, hey, yes, I have these sets of requirements I have, but I can also assign them at different levels. Because if I think about my resources, I'm just drawing Azure here. There's actually a whole structure. I can think about, well, hey, there's management groups, which is this hierarchy of organizing my different resources. That could be dev, that could be prod. And then under management groups, I create kind of one or more subscriptions that actually contain my resources. And then they contain one or more kind of resource groups. And at all of those levels, I can apply policy, policy, different policy to this subscription. Hey, different policy to this resource group. So I can apply those policies at very granular different levels. And I'll kind of get the sum. These are inherited down. So at the top level, it's maybe policies that are corporate-wide, must have. Maybe production and dev have some different policies about types of VM SKUs I can use. Maybe certain types of replication I must have, certain logging I must capture. certain projects, or maybe they have different policies. But I can really drill down all of those different ways. And these are enforced no matter how I try and interact. So as an example here, what I have it over, I have a number of different, I've got this policy test resource group. And in this policy test resource group, I've got things like, hey, only certain locations are allowed. So if I do my edit assignment, hey, I'm restricting the locations, and the actual parameters, I've just selected the only locations are, you can see here, Central US, East US, and North Central US. So that's one of the restrictions I have. I can also see storage account SKUs are applied at the subscription level. And for the storage account SKUs, this time I'm allowing all of them except ZRS, zone redundant storage. So we can see that in action. So if I quickly just jump over and let's actually try and create a storage account. Now remember, one of them was only linked to a certain resource group. So I'll actually target that particular resource group. I have to give it a name, SAB test allowed. And let's target a region that wasn't in that list. So I don't think I had West US 2. And we will pick ZRS. Now notice straight away, before I've even done anything, without clicking create, it's already told me policy validation error. West US 2 was denied. It's not going to let this even continue. It's checking in real time through the portal. Hey, you're not allowed to pick that region. If I go and create, it's going to do a validation, well, it's going to fail. And notice it's failed for two reasons. Hey, your SKU is not legal because I did ZRS, and my location is not legal. So that's through the portal, but the same thing would apply no matter where I try and create things. Now, if I was to change this to one of the legal locations, so notice that warning's gone away, and if I change this to GRS, and now do review and create, now it passed the validation. So you can see in real time I get the feedback. As the user, I could absolutely go and click that link and see the policy. I could put useful text as that IT admin, so they would understand, oh, this is why it's failing. And again, that's going to happen no matter what I actually do that from. So for example, let's actually jump over. If I go and let's go and look at our DevOps, and we go for our infrastructure as code. So from here, what about if I try to do exactly the same thing through PowerShell? Is it now going to work? So notice I'm trying the same thing. I'm trying a region that's not allowed. I'm doing North Europe, and I'm doing standard ZRS. So we saw it fail through the portal. What about if I try and do it through something else? So if I run this, it's disallowed by policy. Error, non-approved region. If I actually get the last error to a variable and dump that out in a friendly JSON, you can see, yep, I'm breaking the US locations policy. You can kind of see errors there. But if I keep scrolling up, you'd also see, so that was the region not allowed. But yeah, if you keep going, I'll also see things about storage account SKU is not allowed either. So no matter how I'm actually creating this thing, it's not allowed because it's been implemented at that RESTful API. It's not just something in the portal, it's actually at the Azure Resource Manager that actually stops me doing that. And again, this isn't just enforcement, as we kind of saw in the nice little picture, it will actually help me do that from a compliance point as well. I can actually go and look at my policy and I have this overview. I can see, hey, how compliant am I? I could drill down into this. I could go to my compliance tab and see the detail of all of those different policies to help me track. So this is a key part. I want those guardrails in place right at the start. Now, make sure you have standards. I want naming standards. If I'm using tags, which is key value metadata, that's really useful to track information about resources, have those defined. Now again, in Azure, there are documents that help me, hey, with naming conventions, gives a lot of suggestions around components of the name. There are documents, and again, all of these are linked actually in the description. I put these in the repo. Hey, how to think about tagging, key tags that we recommend are there. So all of these different components, I want to make sure I have to really track and make sure it's useful, all of the different resources that I actually have. So we think about, yes, I want to get all of those things in place before I start creating any actual resources. But let's say we've got that. Okay, John, we get it. We want policy for the guardrails. We've got these naming conventions. I want to create some stuff. Okay, so we think about this idea that we want to create things. We want to create it as code. We want these declarative technologies to go and create the things. Now, the first thing is I actually have to pick a technology. Now, I can absolutely think about, okay, great. I have some cloud. So I think, okay, I've got some cloud environment. I'll draw this big, make sure I've got enough space for the future. But I have some cloud. And I think about, hey, I want to create different types of infrastructure. Now, that infrastructure could be virtual machines. It could be container environments. It could be Kubernetes. It might be, hey, I'm creating a database. I've got some database. It could be just a regular storage account. But I'm creating certain types of resource actually on that. And the way I want to think about actually creating that resource, remember, is I want a template. I want some declarative technology where I can specify this is what I want it to actually look like. Now realize, I don't want to have to modify the template as I move through environments. Remember, we've probably got a dev test, maybe an acceptance test, and a production. I don't want to use different templates. I want to make sure what I'm deploying is consistent across the environments. I want to have different templates for different environments. But what I will have is maybe different naming, different sizing, different numbers of instances. So I have one template that I version control, but then I can add in per environment parameter files. So it's using the same template, but maybe dev test has one set of naming for the database and a certain size. Production has multiple instances and different naming and different resiliency. But it's the same actual template I'm using across the different environments. Now, I want to try and limit the number of technologies. We always want to be able to use the same thing, be it on premises, in the cloud, in different clouds. So the first thing I have to kind of decide and think about on what technology to use is, as a company, am I multi-cloud? Or am I kind of hybrid? Am I using the cloud and on premises? If the answer is yes, ideally I want to find a technology that I can use across them. Now, a very popular one right now is something like Terraform. So Terraform gives me this ability to have these providers for different environments. Hey, I can have a provider for Azure, for AWS, for Kubernetes, for VMware. And what this actually does is, this is declarative. I'm saying, hey, this is what I want to actually happen. It's a single syntax for this. I create these Terraform files. I have this kind of TF file. Now realize I do have a provider for each of my different kind of target environments. It's not like I can just take a Terraform file I create for Azure and deploy it to AWS. The resources are still different, but it's the same syntax, it's the same technology. But it doesn't just mean I can transparently take one file for one environment and apply it somewhere else. I would have to modify it. Now the way the Terraform works, I create these Terraform files. Again, I can have parameter files. And the way it works is we kind of plan it out. We plan out, hey, what is going to happen when we execute? That is this whole idea of a state file. Now, the reason it has this, remember, is, well, it supports all these different types of possible environments. And so to work really efficiently, it has to track what it believes the state of reality is. Now, it does some checks and refreshes, but this is what it believes the state of reality is. So when I have a new desired state, it compares that to the state file, and that is actually going to now work out what is the plan. What should I actually do? And then when I actually do the apply, well, that's going to govern the kind of resources which feeds back into an updated state file. So it's this process. So this file here is really important. I can get in a world of hurt if something bad happens to my state file. So we want to protect this. If this was something I was storing like locally, I could store this in a blob, for example. I'd want to make sure it was GRS, so it's redundant, it's protected. But if I'm doing multiple deployments at the same time, that file might get locked. So then I struggle with certain things. So Terraform actually has a cloud solution where it maintains the state file. I can kind of just submit, hey, I want these deployment jobs done. It has secret capabilities. It's free, I think for teams of up to 5 for one concurrent run. Or there are paid plans for multiple concurrent runs for bigger teams, for example. There's private installations using enterprise. But Terraform is really attractive in that it's multi-cloud, it's hybrid. I can use this one technology, and it's not unique. There are other technologies that can do this as well. It's just Terraform is very, very popular right now. But it's this idea that, hey, I can use this to specify what is my desired state. And remember, this Terraform file, where would it be? Well, where's it going to be is in my repository. These are all in my repository. So I can version control it. It's centrally stored. And I'm going to keep drawing different repos, but think about it's the repo for my project. So these are all going to be stored in the same repository I have. So, hey, great, I can version control this thing. I'm centrally managing it. I'm tracking it. This work to AWS, to Azure, to Kubernetes on-prem, to VMware, wherever that may be. Terraform even has a Sentinel technology. I talked about policy. It can have policy defined at Terraform to check, hey, am I doing something I shouldn't be, and actually stop it proceeding beyond there. So this is a really attractive technology if I'm kind of multi-cloud, if I'm hybrid. What if I'm not? What if I'm just, no, I'm one cloud? Well, I still might opt to use something like Terraform. There may be features in there that's just appealing to me that makes it worth using that technology. Or I could use a native technology. So in my example, if this was Azure, well, for Azure, there's kind of these ARM JSON templates. Already the new thing is something called Bicep. And I have links in the description to all the different videos in the GitHub repo about deep dives into these technologies. But Bicep is this new language that's very easy for us to humans to use, where I can define what I want my state to actually be. So it's kind of this key point to using these technologies. So I can use something native. And again, all of the main cloud providers, they have these capabilities. Let's just quickly look at an example of one of these. So if I jump over again to here, so what we're going to look at this time is actually a Bicep deployment. So we saw a portal, we saw PowerShell. Now I can think about a Bicep file. So if I go over to here, so notice I've got some parameters I'm getting passed in to the file, a storage account name, a SKU location, and then I'm just saying, hey, I want to create a resource. The resource name in the parameter file is just going to be like a reference is STG storage. This is the type, so it's a storage account at the storage resource provider and a version. And it's got some attributes, hey, a name, a location, a kind, and the SKU. So I'm just stating what I want. I want a storage account. I want it in this location. I want it of this kind. I want it of this SKU. And then here I have different parameter files. So I have a parameter file for dev. Well, I'm picking ZRS. It's probably not going to go very well in North Europe. And then I have a good parameter file, hey, standard LRS and eastUS. And I just call these files. So if I think again about our kind of demo file over here, let's quickly go into this folder. I can say, hey, I can do what if. Tell me what would happen. I'm just going to do a deployment of that template to my resource group with the bad parameter file. So if I execute that, hey, do this execution, there's no state file with Bicep. It's just comparing it to the actual reality that exists at this time. So I don't have any state file I have to worry about. It's just working directly off of reality. So it's checking that. So it's doing a quick look. And it's saying it failed. Well, it failed because of policy violation, non-approved region. And again, I could look at the detail. Now, if I deploy it with the good parameter file, and again, I'll do what if again. Again, it's going to compare it to reality. Hey, what's reality right now? And it's working out what would it need to do. And this should work because those parameters are not going to violate the policy. It should be in a good position. Now, while that's running, notice it's going to create it. Notice it's also adding a tag that I didn't specify, but in my policy, I have, hey, I want this tag present. So if I just went ahead and ran this, so we just run that. If I go quickly jump over to my resource groups, and we'll look at that policy resource group, which was empty. So there's nothing there right now. But what this should do is actually go and create that resource to that actual configuration. So it's looking at reality. Reality is that's not there. And it will go ahead and make it so. Now notice I actually overrode something. I'm actually passing storage GRS. So it's actually going to make it a GRS even though my parameter was LRS. So I didn't actually mean, I ran the wrong command. That was the second demo. So it's going to make it as a GRS. So let's refresh. Portals can take a minute to catch up sometimes. It's not showing it, but it is there. So get refresh again. There it is. There it is. It created it. And you can see it's GRS. Now let's run this again and actually run the first line. Remember, in the parameter file, it's saying it should be LRS. The only reason it did GRS is because I overrode it in the execution. So I'm going to run it again. So this is my desired state is that I want this storage account to exist, but I want it to be LRS. So maybe I've changed it in my repo to now be LRS from GRS. I'm not giving it a different command. Now it says it's finished. And notice it's saying, hey, storage SKU LRS. It's showing me that actually over here. So it's gone and it's worked out. What does it need to do? And if we go and look at reality, and we refresh, now we're looking at this over here. This was geo-redundant. All I did was rerun the template with just different, basically, parameter value. Now it's LRS. If I ran it again and again and again, it wouldn't care. It's just going to make sure, does reality actually match? So I've got all of these capabilities just present for me. So that's the key point of this. It's idempotent. I can rerun this as many times as I want. It will just make it match reality. And again, those Bicep files would be in our repo. Now, what about if I need to perform some other action that's not possible in the template? There are things like deployment scripts. Maybe I need to add some additional users to some permissions that I can't do with a template. Most technologies will let you be able to run arbitrary commands in some temporary, ephemeral, maybe container. So for Azure, I can do a deployment scripts component that I can run any commands I want. Or I could call an Azure automation. There's ways I could accomplish that. Now, so the first thing we're going to do with these templates is integrate it with our pipelines. Remember we had that pipeline. It's too far away. But we had this pipeline all the way up there. I'm not going to try and draw an arrow from there to there. So we have this template idea. Well, I have my pipeline. I have the pipeline right here. That Bicep file, where is that? I have a repo. So I have some repository for my project in there is my .bicep file and my .json file, which is kind of my parameter file. They are sitting in that repo. So what my pipeline is going to do is, step one is, hey, check out the repo. So it has the content of that code available. Step two, well, I probably need to authenticate. Step three is going to be deploy. And when it deploys, how does it deploy? It uses a template to actually go and deploy those things. Now, there's a certain set of sequences that have to happen here. Remember, to authenticate, when we're running this is our pipeline. This could be GitHub, for example. Well, our pipeline, I could have a credential as a secret. So, hey, it uses a credential from my repo. My deployment, or maybe there's kind of an environmental variable that sets the subscription. Because I want to use the same template and just modify where I'm deploying it to. And then there's other kind of steps as well. So all of those things really kind of come together. So let's look at this. So the idea of using the template from a pipeline. So what I've actually got over here is I can think about what I actually want to do really quick is I'm just going to delete this because I want to actually see it created from our pipeline. So that same bicep file I manually executed, we want to use that actually from GitHub. So if I was to actually look, hey, I've already uploaded these, and there's my bicep file under the part 06 IAC with the parameters. Great. Now, two things before we go any further. If I look at my settings, remember, I can have secrets. So I have a repository secret of Azure credentials. So this can be used by any environment. It's just there at the repository level. But then what I actually did is I have an Azure sub ID, one value for QA, one value for test. So test is actually my dev subscription, QA is my lab subscription. So now what that means is depending on which environment I target, I get different subscriptions where I'll actually create resources. So if I now go to my actions, so I created a deploy bicep demo. And if we look at the YAML file, what are we doing in here? Now, I've got mine configured as manual execution, just because I didn't want it triggering automatically. I have a job, deploy infrastructure, that I'm using against environment test. Now, environment test, remember, maps to my dev Azure subscription. I'm going to check out the repo. Then I'm going to log into Azure, and I'm using the repo level Azure credential secret. So I'm now authenticated to Azure. Then all I'm going to do is using the ARM deploy, I'm going to get, remember, the environment level Azure sub ID. So I'm going to target that for the subscription. I'm deploying it to my policy test. I'm passing it that bicep file with my bad parameters. So now we're actually doing it from a pipeline. We're going to trigger this. So that's the code we have. So from here, if I run the workflow, we'll actually kind of see, so we can see now it's queued, we can click on it, we can see all the different parts that are going to happen. So it's waiting for a runner to trigger this off, but it's going to check out the code, it's going to go and authenticate. So there we go, we checked out the repo, we're authenticating, all good. We're deploying the bicep file to that subscription. And remember what I have in here, oh, it failed. Oh, I've got these nasty failures. Why did it fail? Well, no surprise. It failed because of policy violations. All of the same ones. Storage account skew, because it was ZRS, failed. I'm also going to see in here the region. So non-approved region, that's kind of the line above it. So that policy was enforced everywhere. This is why we love policy. Now I could obviously go and kind of fix that. So if we go back out, instead of doing the bad file, we can edit directly in here. If I change it to not.bad, it'll just be my parameters file, and we'll just commit that. So now we have passing it the good parameters file. If we just run that again, now remember, right now, if we looked at our resource group, it's empty. There's nothing in there right now. So now it's deploying again. It's going to find the job. It's waiting for a runner again. And I can run this as many times as I want. It's just going to make sure it matches this state. It's not going to error if it exists already. It's just going to work. So hey, set up the job, and we're just going to see it run through. And this time, because it's good values, we should absolutely see this work. So we're going to log into Azure. Yep. We should see the deploy Bicep file. Validating the template. Creating deployment. And we should see the resources. So that's the whole goal of what this is doing. Notice it's taking longer. So touch wood, it's working this time. And this won't be a miserable failure of a demo. But it's going through. So I'm expecting that fully to work. And the point is, this could run at every single time the pipeline kicks off. If the resource exists already, it doesn't matter. It's like, fine, I don't need to do anything. But it's a way to validate it definitely is matching my desired state. It's idempotent. I can run this as many times as I want. It will just make sure it matches my desired end state. That's all this is going to do. So that's why this is so powerful. Let's just go back, try and prove the point that it actually works. So it's still running kind of that deployment, but I fully expect this just so we don't have to wait too long. We'll see if it does come back, but it definitely should work. But if I go back for a second, you can see here there was one I ran. This was actually where I changed it to the good file. And here you can see it deployed it just fine. You can see that was successful. But let's go back a second. Refresh. And it worked. There we go. Deploy Bicep demo. And it did work. And so what we should see now is that if I refresh, and again, this can be a little bit behind, but it just finished. But we'll keep hitting refresh. What I would expect to see is that storage account. Within about 30 seconds, it would show up in the portal. So that kind of shows it goes through and actually creates those resources. Although for some reason it's taking a really long time because I'm trying to record a demo. But we did see it was successful. There were no errors, there were no policy violations. So we can actually see through our pipeline, it actually went and deployed those resources. I think if I actually went and looked at the storage accounts, let's go back in maybe. It's really taking a long time. Oh, there it is, now it showed up. There we go. So we can see it actually did create. So that's the point of that infrastructure as code. And again, I could rerun that. I could just run again. It wouldn't fail because it already exists. I'm just saying my desired end state. That's kind of the key point. So that's what we want for our infrastructure. Now, what are we creating in that infrastructure? Let's say it's a virtual machine, the most basic thing. Well, storage account is probably the most basic thing, but let's say a VM. What does that VM really comprise of? Well, that VM really comprises of things like, hey, I have an operating system. On that operating system, we might install runtimes, middlewares, our applications itself. So how do I do those things? How do I make the OS match my configuration? Now, there's really two levels to this. as much as possible, I want to try and avoid having custom images. So let's put that to the side for now. How do I configure the operating system, be it Windows or Linux? So I think about the configuration. And once again, our goal for the configuration is some kind of declarative technology. Now there's things like PowerShell, DSC, desired state configuration. There's things like Chef Inspect, Puppet, Ansible. There's all these different technologies, Ansible, that I can apply to say, I want the OS configured this way. I want these apps present. I want this middleware present, this runtime here, it configured this way. So the whole goal around these, for the most part, is these are declarative. I'm stating my desired intent, which again means I can version control them. I can see drift. I have all of those capabilities on these things. Now, as I talked about earlier, I said Terraform. Well, Chef and Puppet and others, they can do that same kind of multi-cloud capability of the infrastructure as well. I'm kind of focusing here on the configuration inside the OS. But again, I'm going to state my desired intent. Now, from a native kind of technology, one I've used a lot is PowerShell desired state configuration. So here I'm looking at this file, IIS install. And you can see, what am I doing here? I'm saying, hey, I want a Windows feature IIS to be present. And the actual feature is called web server. I'm not telling it, hey, install it. I'm saying I want it present. Then I'm saying I also want the Windows feature ASP.NET to be present. And then I'm using an extension to say, hey, the default website, I want stopped. That's my desired end state. And then I'm saying, hey, some files from one location, I want to be present in another location as well. Basically, make sure they're copied there and match the state. And then I want to make sure there's a website called Savil's site that links to this path to be present and started. So I'm not telling it how to do it. I'm saying this is my desired end state. So again, it's idempotent. I'm stating this is my desired end state. Go and make it so. I'm not telling it how to do it. I'm just saying this is what I want reality to look like. If it's there already, great. If the files have changed in that source, excuse me, make it match. Copy over whatever's changed. If a file's modified, make it match. Whatever it is, this is just my desired state. Go and make that the reality of the situation. Now, I talked about Azure Policy earlier. Azure Policy actually has an in-guest capability that uses PowerShell DSC for Windows and Linux, and it also uses Chef Inspect for the Linux as well. So using Azure Policy, I can define things I want in the guest using that one technology. So there's declarative ways to handle configuration inside the OS. And again, all these files would be in my repo. That's kind of a key point. Now, what about if I do need custom images? As much as possible, we want to use the kind of vanilla images from whatever cloud vendor or whatever we're using. But what if I do need a custom image? So most of the time, if we need a custom image, there's kind of this idea that there is some gold starting image from maybe the marketplace. So we'll say, hey, this is the gold image over here. This was provided for us. But what we have is some kind of customization. There's things we want to do. And we're going to store that in our repo, because that's our desired intent of what we want the things to actually happen, so we can version control that. And what we then have is some kind of technology. A very popular one is Packer. And that's from HashiCorp, actually the same people that do Terraform. And that will take those customizations that I've defined, apply them to some starting image, and it will spit out my custom image that I would typically put into some kind of shared image gallery that could then be used by my environment. So I'm going to store that. It could replicate to multiple regions so it's easily usable. And I could then use that to deploy those base VMs. Maybe it's got certain agents pre-installed, certain key configurations. I just have to have. But the whole point is this is the desired customizations that Packer will apply. Now, some clouds have these technologies built in. Azure has Azure Image Builder that's built on Packer that I just give it the customization and it will go and spit those out. As I change it, it will create new versions. And the nice thing about these kind of images, they can be versioned. So version 1, 2, 3, 2.3.4, whatever that is, so that as a new version is released, maybe technologists go and see a new version and stage it out in a controlled manner. So I can do those various things. So that's great. If we think about that, we've, from a declarative perspective, deployed the infrastructure, configured the operating system and the apps and the runtimes. Even if there's custom images, hey, I'm using infrastructure as code to define what I want the customizations to build the images. Everything is based on something from a repo that's version controlled. I can rebuild anything. I can rebuild my custom images. I can redeploy the environment. I can rebuild the infrastructure all from my one repo. Everything can be built. And that's the key point. When I have this as code, I can see exactly what's been done. I can see the version that was used. I know exactly what I have at any point in time. So let's continue to build on this. That was a VM. What about if it's containers? Well, containers, so we've got this Kubernetes environment. Kubernetes is kind of that orchestration layer for containers. So a container, fundamentally, we have a container image. Now, a container image is really built on layers. There's kind of these multiple layers, some base OS, some tweak to the OS, some customizations. Then you have like a read-write layer at the top, so I can actually modify things. So we build container images from layers. We store these in some kind of container registry. That could be Docker Hub, that could be Azure Container Registry, whatever that might be. Now, the way we get those images, well, it's layers, remember. So the chances are there's some kind of base container image. Maybe that's a certain OS, an Ubuntu, or maybe a Windows Nano, whatever that might be. So we have that container image, which itself might be built from other images. Again, remember, it's layers. So someone built that image. But then what I have is what I want my container to look like. Well, we have a Docker file. That Docker file specifies the changes we want made to create our container image. And guess where that is? It gets a bit redundant after a while. It's in my repo. So I can version control it. I can version those things. I can see what happened. And we basically, through Docker, we go through a process. We take that and we apply this to build our new container image. So that's kind of a step one. So I have to be able to create the container image I want to use. Well, we have a Docker file. Now, this is something we're covering next week. Next week is containers and Kubernetes and GitOps and that sort of stuff. But just to kind of quickly show it on part 7, if I look at my Docker, I have a Docker file. And we can see, hey, I'm building off of this container image. I'm making a change to it. I'm deleting its default web page and putting in my content. That's it. And that's going to spit out, if I actually do, you can see here I'm doing these builds. So I can run, I'm pulling images, but you can see here I'm building my own container image called Bad Father, the thing I demo all the time. So you can see I actually build it by using, hey, the content of this. So in this website, in this file, is all of this actual content. So again, I have this very prescriptive file with the Docker file of what I want to do. And from that, I can recreate my container images very, very simply. So again, everything is building on everything else. So we have this container image. That's kind of a key step. So that would be a container. Now, if I think about more larger scale, we use Kubernetes. And the whole point of Kubernetes is I tell it what I want. So, okay. So for Kubernetes here, what do we have? Well, what we have is we have our Kubernetes deployment YAML file. And guess where that is? It's in our repo. And that YAML file defines, it's declarative, our desired state. Hey, I want X number of these pods on these worker nodes that have these taints and these tolerances. I want this service available on this port. So what this essentially does is, hey, oh, wrong color, disaster. Never use that color. All right. Hey, deploy. I'm doing a deployment and it's going to use particular images as part of that. So when it does this, what it's going to spin up are pods, maybe multiple pods depending on the config that runs my container image and a container instance that offers my service. There's other things, there's services get spun up, which maybe internal or public IPs with so all these various things that happen, but I'm essentially doing a deployment from this YAML file that states my desired configuration. If we go and look, and again, I'm going to cover this next week in detail, so don't worry really a lot about this. But if I go and look now at this YAML file, this is for Kubernetes, I'm stating what I want. Hey, I want one replica where, hey, I'm Azure Vote Back 1. This is the template. My label is Azure Vote Back 1, but my image is going to be the Redis image. And then my resources, I specify what the resources are, what ports I want. Then I have a service that I want. Then I want a front end deployment with one replica again. This is built off of a different image, v1 of this one. And then I want a service that, hey, it's a load balancer, and there's the spec, hey, it's a load balancer, and I want to offer 80, and I would deploy that. I'm stating my desired end state. If it was deployed and then I changed my desired end state, like I comment these lines out and make it an internal load balancer instead, it would modify what's deployed to match that new end state. And again, we're going to go through this in detail next week. But it's declarative. I'm saying, what do I want my end state to be? Again, it's as code. That's a key point to all of these different things. And once again, there's an idea of policy. So there's something called gatekeeper for Kubernetes. So with that, I can kind of put a policy around this. For Azure Kubernetes services, it actually has Azure Policy for containers that uses gatekeeper underneath. So I can define it using Azure Policy, one place, but it uses different technologies to actually do that enforcement. So I could enforce those deployments at the Kubernetes level as well. So we have that single technology. Now there are other components. There are things like Helm charts. If I'm doing multiple YAML files, it brings in multiple services to provide an application. Rather than me manually working out which bit to use, a Helm chart is basically a structure that says, hey, these are all the different YAML files that make this up, and I can deploy the Helm chart to get a complete solution deployed for me. Something else we're going to talk about next week is GitOps. So GitOps is the idea that often we think about, from all of our deployments, it's the pipeline. There's a pipeline running that it goes and gets the repo content and it pushes it to the environment. So in this case, there will be a pipeline that grabs the YAML file and applies it to the Kubernetes. That pipeline has to run to actually make that happen. Well, there's another concept. We'll use gold. I'll get out the gold pen. So there's this whole idea of GitOps. So GitOps is there's this Flux component. So what this Flux does is a number of different things. But this operator runs as pods. So I can kind of think about, I'll just draw Flux. Now it does interact with other things. It does utilize things like Helm operators. But fundamentally what it's going to do is it's basically synchronizing a repo of YAML files. So it's looking to see are there changes made to those YAML files. It's also watching, hey, is there a new version of an image released? If it sees, hey, there's a new desired committed YAML version, i.e. I've changed what I want to exist, maybe I've changed the number of replicas or a new service, if I've got a new version of the image, it will actually apply it to the Kubernetes environment. So it is actually, I'm not having a pipeline run. What's happening here is once I do the commit, maybe to my main branch, it will see there's a new desired state and it will apply it. If it sees a new version of the image, oh, I'll go and update. So this basically runs itself, but it will deploy those things. Now, again, to deploy this initially, I could deploy it as code. I could have a template that goes and deploys this Flux GitOps environment to here. So I can still use all of those different capabilities, but this is super powerful. So this isn't a pipeline, this is natively just running, and hey, as I change my desired state in my repo, it's synchronizing that constantly. We'll see it and apply it. I drew a database up here. What about databases? Well, how do I normally define a database? Most of the time for a database, I have SQL files or some other structure that is my configuration. Well, guess what? Those SQL files I'm going to store in a repo. As part of my pipeline, I can apply that to create my schema, to create my tables, to modify whatever it is I actually want in that environment. So every element, I never want a human clicking things or doing things. Every element is as code, everything. Creating the infrastructure, define the state of the operating systems. If there's a shared image, what's running inside. Hey, creating my container images, deploying my Kubernetes environment, configuring my databases, which we created with the infrastructure as code. Everything is as code. And I've got these million different repo buckets all over the place. But I mean, the key point here is, yes, I drew lots of them so the picture makes sense, but it's one. I have my project repo. Remember, that gives me the version control. It's centralized. All of these are prescriptive, so I can understand. I can easily track. I can track what's deployed. So in this, I have my Bicep files, my Terraform files. I have my JSON files, which are kind of my parameter files. I would have, for example, my PowerShell DSC, or my Chef, or my Puppet, the configuration. I would have my Docker files to create my containers. I would have my Kubernetes YAML manifest files for what I want that configuration to be. I would have my SQL files in here. Those Packer files, I'd have my Packer files in there as well to actually, with all those customizations. And what's interesting, all that Azure Policy stuff I talked about, well, I can do policy as code. So once again, what's interesting here is even the IT admin, I don't want them clicking the buttons. All of that can be defined as code. Like all of that policy stuff I did, remember I said it comes through as ARM, I can define policy using a template. So even the IT admin, yes, the world has changed, but that IT admin here, when it does that configuration, guess what? They can do all of that configuration as code. They can have that checked in to a repo. And guess what? As they commit that in, that could deploy via a pipeline. They could actually have a continuous deployment. So as that goes through, it deploys the new version of the policy to the environment. That's this key point. So all of these things are in this repo. So it's version controlled. It's prescriptive. It's saying what I want. Ideally, it's declarative. Sometimes it's not, but we want it to be declarative because declarative gives us that idempotency, i.e., I can just keep rerunning that as every time at the start of the pipeline. It doesn't matter. That makes it auditable. I can track compliance. Is there drift? Is there not drift? So those are key points to everything we're doing. So yes, I drew many, many different repos. There are not many, many different repos. There could be, depending on the project. Like policy, well, it's probably complete. That's not project specific. That would not be in the project repo. I don't want to duplicate code. That would be somewhere else, and I could reference, or that's centrally managed through those various deployment points. But I have all of this goodness. I have not clicked a button in a portal. I've not manually run a script. All of this I can do as code, and that's critical. If I think about those pipelines, I need to make sure it's repeatable. I can track it. It's not someone doing maybe something different between environments. It has to be consistent. All of my environments in my stages, be it dev and QA and production, they all have to be production-like. Might not be the same scale, but they're configured the same way to make sure my testing is valid. This lets me do all of that. So this is a key point. So infrastructure as code really is kind of a key cornerstone to everything we're doing. So I really hope that made sense. I hope that was useful as ever. This was part 6, and as I was trying to stress, all of this is in the repo. So right now we're on kind of part 6 as we look. So all of the whiteboards, all of the code are all available. Link to the videos. Other videos that go into more detail, I'll add 6 by the time you actually watch this. Obviously also there's the playlist. I do recommend you kind of start and walk through this kind of in order. They do build on each other to give you kind of that complete view. But it's all there available. As I always say, a huge amount of work goes into creating these, so I really would appreciate a like, subscribe, and share it with others if you find it useful. But until next time, take care.